Hello, and welcome to IoT Builders, a live stream where we discuss a range of topics on the Internet of Things for builders. My name is Dan Gross, and I am a senior developer advocate for FreeRTOS and AWS IoT at AWS. I'm joined by my colleague and co-host, Nenad. Hi, Nenad.
Hey there. Yeah, I'm Nenad Ilic. I'm a senior developer advocate at AWS, working with developers around IoT, mostly in automotive industry as of now. Thanks for having me.
Fantastic. Hey, on IoT Builders, we're discussing everything from embedded devices to cloud services, all relevant to IoT. So this is our first episode, and today we have Ed Miller from ARM joining us as a guest to talk about ARM virtual hardware, Kyle Studio Cloud, and ARM Dev Summit, and maybe some other topics. So hey, welcome, Ed. Why don't
Then
you?
it seems that we cannot hear you.
Can you hear me now?
So yeah, it seems that Dan has some issues with the microphone, so we cannot hear him. But yeah, as he started talking about, we have Ed Miller from ARM. Yeah, maybe Ed, you can introduce yourself.
Hey, Ed, are you there? We're working out the technical details here on getting
Yes,
Ed
I
to be a
think
speaker.
I think at the moment Ed is just a listener. I think he needs to join as a speaker as well.
Let's see. So I've invited him to speak. Let's see here. One moment.
Yeah, so I think in general, if you are invited as a speaker, you need to accept. Yeah, and then it will ask you, yeah, kind of a question to allow this. Option.
Okay, well, we're working on trying to get Ed to join as a speaker here, but Nenad, so this is this is our first episode,
Yes.
and one of the topics that we were going to discuss was around ARM Dev Summit.
Yes.
And I think both you and I have speaking slots there. ARM Dev Summit, as we were informed, is now moving to a virtual event, but I think there's still going to be some great content lined up. Maybe you can tell us a little bit about your talk coming up at ARM Dev Summit.
Yes. Yes. Unfortunately, as you said, we will not be there to see people. But that being said, having also this virtual allows us to kind of present this in a different manner, so people can, even after the sessions, watch the videos at their pace. So I will be talking about managing the IoT fleet of devices and doing some A/B testing in terms of like how you can integrate the CI/CD pipeline and basically have applications that you develop deployed to different group of devices and perform some kind of A/B testing, more or less. So that's going to be the talk. I'll have a demo at the end. So it's going to be interesting, I would say.
Oh, that's great. That's really great. Yeah, I think as we just mentioned, ARM Dev Summit will be going virtual, but still talks are being scheduled. Oh, hey, there's Ed. I think. Let's see here. Ed is now a speaker. Can you hear us, Ed?
Can you hear me now?
We hear you well. Yeah.
Yes, we can. Yeah. Yes, we can. Very well.
I ended up joining from my phone. Thanks for the pointer. I never got the option to switch to a speaker on the web browser. So anyway.
Yeah, pardon us. We're just learning the platform, and as it turns out, it looks like we can't speak while we're on the desktop application. You need the mobile app for that. Okay, learning curve, but we're getting there. So hey, Ed, I think I left off asking you to introduce yourself and maybe a little bit about your company and your role, and we can get into it.
Sure thing. Yeah, Ed Miller. I'm a senior principal engineer at ARM. Many of you know ARM is the developer of the ARM instruction set architecture, pretty common architecture across all sorts of devices, from the cloud all the way down to the tiniest edge devices and just about everything in between. And my role at ARM is I lead a lot of the technical engagements with some of our key software partners, and especially AWS.
Fantastic. Yeah, we really appreciate your partnership, and I know that we've done some really great things together. Now, also, you happen to be an AWS community builder too.
That's right. I joined the AWS Community Builder program at the beginning of this year. I'm actually in the machine learning track within that programming. Within that program, they don't have an IoT track at the moment, but I certainly make a lot of plugs around IoT to try and keep the community interested, and hopefully there'll be some additional growth there, and we'll see a track coming up there as well. But yeah, it's been a really great opportunity to get to meet some of the AWS community folks. I think there's a few thousand individuals around the world in that program. It gives you an opportunity to learn a lot about what's coming from AWS and interact with a lot of other developers and builders that are using the services. Learning from them and sharing what you know. It's a great community.
That's really great. That's excellent. Yeah, we'll have to change that. There has to be an IoT track.
Absolutely.
And of course, we're ML is we could consider perhaps IoT adjacent, but not quite. So we'll have to change that. Okay, so on this program, we wanted to talk a little bit about ARM virtual hardware. This is a newer effort that ARM and AWS have collaborated on, and maybe you could tell us a little bit more about what ARM virtual hardware is, and then we can dive into some details around that.
Sure, sounds good. ARM virtual hardware, it's a family of functionally accurate representations of ARM processors, systems, and third-party hardware. And so, basically what that means is it's a model of what a real processor does and how it functions. And we've got two main classes of those ARM virtual hardware solutions. One, it represents our kind of core processors themselves. So the ARM Cortex processors, like a Cortex M4, which is a very common processor in microcontroller space. And we also have something called the Corestone systems, which are subsystems built around a processor, maybe plus some additional logic around it. So, for example, we have something called the Corestone 300, which is our Cortex M55 processor, and an Ethos U55, which is a micro NPU, or a neural processing unit to accelerate machine learning for very tiny edge devices. And we've also got a second class of ARM virtual hardware for third-party hardware, where we're actually emulating a system at a board level. And so this is a new offering for us, which we just launched more recently, and we have a few boards there so far, and we're working to build out some new ones. And that includes, we have a virtual Raspberry Pi 4, since that's a very popular platform to utilize. We have NXP IMX8, and we have a STM32U5 discovery kit from ST Micro. So yeah, those are the solutions that we have for ARM virtual hardware, and the intention is to be able to get up and running for application developers that are developing applications for embedded and IoT solutions. They can utilize these devices. They can utilize these virtual devices even before silicon exists, or they can also leverage them in CI/CD development environments. So instead of trying to build up a board farm, you could run your applications on these virtual hardware devices to do testing. And so I think we also see this bringing edge devices into the reach of the cloud developers, the DevOps and MLOps engineers that are responsible for these IoT devices. Now they can build fleets of virtual devices and test scenarios of deploying new software from the cloud onto these devices in a virtual context before they do it out onto the real fleet of devices in the field.
Yeah, that's fantastic, and I think that it's really cool that it's both microcontrollers as well as microprocessors being modeled there. And you mentioned the U5. I think some of the supply constraints, have created an environment where it's sometimes difficult to procure some of this hardware, right? Like the STM32U5, which is a great platform. But it can be quite helpful to be able to have a virtual U5 in the cloud.
Yeah, absolutely. Maybe you have one sitting on your desk, but maybe you want to run scenarios where you're testing a multitude of them, and you might not be able to go out and source U5 development kits so readily, or you may not have a lot of your own boards available. So yeah, the virtual U5 gives you that ability to run some multi-device scenarios that might be more difficult otherwise.
Yeah, and it's a little bit different, thinking about this ARM virtual hardware versus simply ARM instances. I mean, so AWS has Graviton based on the ARM instruction set, and that's really for cloud hosting essentially. But this kind of takes that to a different level, really thinking about IoT and the things that you're managing. Both within the cloud as well as out on the edge, and so it kind of brings that physical perspective, even though it's actually virtual.
Yeah, that's a great point, and Graviton is something that we leverage very heavily in this offering. In fact, we have a lot of commonality in the ARM instruction set. I think that's one of the powers of a common instruction set. And so, for example, our ARM virtual hardware third-party platforms, they do make use of the Graviton processors as an emulation engine. And in fact, a lot of the ARM instructions can run natively because it is also based on an ARM compute subsystem. The Graviton instances are, and so we can make use of that, and then we can use a hypervisor to to trap on the remaining instructions and make sure that we emulate those appropriately so that we can run actual binary images. So you can run your actual Raspberry Pi 4 binary on the ARM virtual hardware, and it's running on Graviton processors up in the cloud.
Yeah, so I think we both feel that this can really help the development cycle because you're not constrained by just the physical hardware or connecting the physical hardware to your development environment. You can really start writing code immediately against this this virtual hardware, and the firmware itself may not actually change that much when it goes into the ultimate real device. But thinking through that, how does that work? Are the what do you do about things that like sensors or other types of peripherals that that might be accessible on an IoT device? Are those somehow modeled as well?
Yeah, so on the Corestone and Cortex processor ARM virtual hardware instances that I discussed earlier, those are really meant to be the compute subsystem, and they're mainly for functionally testing your code and application. However, they do have what we call virtual I/O streaming interfaces, so you can connect. Essentially, you have a hook to an external process that can feed an input or monitor an output of varying kinds of serial input or something like that. And these things can be controlled with Python code or some other kind of external code running within the framework of ARM virtual hardware, but running outside the context of the device itself. So you have some control over feeding data from a file or saving data to a file or something like that. In the third-party hardware situations, we go through a little bit more effort to try and emulate the actual I/O mappings for the hardware platform that we're looking to emulate, and again provide access and APIs to those interfaces so that again you can stimulate them. So we talked about the U5, for example. We have that. We have a set of sensors that we've connected to that, virtual sensors that we've connected to that emulate things like temperature sensor, pressure sensor, your typical 9-axis, accelerometer, gyro, magnetometer. Yeah. So those kinds of things that you would often have associated with a device like that, and so you can feed those from files or programmatically or things like that. And then, for example, in the IMX8, which oftentimes is being used in conjunction with a camera, you can actually connect to a USB camera on your desktop and have that stream up to the cloud instance, or for scaling out things, you can read video clips from a file and have those have those act as the source, your camera source in test scenarios as well. So we're continuing to grow this space, but we do have a number of commonly used sensors available in the virtual platforms today.
Yeah, that's really cool. Virtual interfaces to to allow you to develop, say your FreeRTOS application, and really, interface with sensors as if it were the real hardware. And I think what's interesting about that too is this is where the format of SimSys packs really helps as well, right? Because some of these are SIMSYS packs essentially that then can get encapsulated as virtual interfaces.
Yeah, absolutely. SIMSYS packs, for those of you who don't know, is a packaging format that that is targeted at the microcontroller space. So for you Linux users that are familiar with apt-get or package managers like that, there's not necessarily a corresponding thing in the microcontroller space. And well, we don't have dynamic libraries and that sort of technology on the microcontroller space, but when we are building projects, we can take advantage of a package manager to understand, for a given application and a given platform, what the dependencies are. What are the packages I need to pull into a device? So if you're targeting a Corestone 300 virtual hardware platform, you can build your application to a set of APIs, and then the appropriate packages get pulled in underneath that to fulfill those. And if you then retarget that same thing for a U5 platform, STM32 U5 platform, Discovery Kit platform, then it'll pull in the appropriate SDK board support package from ST to fill out the rest of that platform and have the appropriate target pieces underneath that. And of course, that can then also run on the ARM virtual hardware version of that same platform.
Right. Yeah. That's awesome. And we've done some work together on SIMSYS packs for FreeRTOS and the libraries around FreeRTOS, especially the LTS libraries. So those were recently released as well. So those would be available in the virtual environment too.
Yeah, absolutely. Making use of FreeRTOS, making use of the trusted firmware package from ARM to utilize security on a V8M platform that has a trust zone capability. That's all available in packs, so you can get up and running quite easily. And then building on top of that with the libraries from AWS IoT for MQTT, for connecting to IoT Core, device shadows, all the different libraries that are available for FreeRTOS are available in SIMSYS packs, and you can get up and running quite quickly with applications utilizing those libraries.
Yeah. So if you're just joining us, we're approaching the bottom of the hour. If you're just joining us, we're here with Ed Miller from ARM. I'm Dan Gross from AWS, and also Nenad Ilic from AWS. And this is IoT Builders. So if you're a builder and these topics are of interest to you, tune in every week. We're going to be discussing various topics around IoT, especially as it pertains to builders. Okay, so let's see. Moving on, I think we talked about ARM virtual hardware and SIMSYS packs, and as it turns out, there's a lab or a workshop that AWS and ARM have collaborated on, and this workshop goes through how to use ARM virtual hardware and kind of all of the getting started steps and that sort of thing. I haven't been personally involved in it, but I know you have. Could you tell us a little bit more about this workshop, Ed?
Yeah, so this is a workshop that's published now by AWS. So if you go to the workshops.aws website and search for FreeRTOS or search for ARM virtual hardware, you should be able to find this workshop pretty easily. And it was built by one of your partner solution architects, Paul Butler, and he and our team have worked together to build out this workshop. And it walks through getting This utilizes the Corestone 300 ARM virtual hardware. So that runs as an Amazon machine image, an AMI, that you spin up on an EC2 instance, and it walks you through the steps of getting that set up. Utilizing a project that runs FreeRTOS and runs that FreeRTOS application on the ARM virtual hardware, connecting to the AWS IoT cloud. And also introduces another one of the development tools available from ARM called Kyle Studio Cloud. And Kyle Studio Cloud is a web-based IDE for microcontroller development. Anybody that might be familiar with Kyle MDK or Microvision, this is the next step beyond that. So we have a cloud-based version of this application. It supports SimSys packs, so you can use the lab would basically walk you through how to pull a project into Kyle Studio Cloud, and you can also use that application to run your application on ARM virtual hardware in the back end. So it's a really cool workshop that walks you through all of the steps. And lest I forget, the other really cool thing about ARM virtual hardware, as I was saying at the beginning, is you can use this for continuous integration. So it also walks you through setting up a GitHub repository of your code. So when you check code into it, when you update your code, it automatically kicks off. In this case, it's using GitHub. There's a number of different CI solutions that are available with ARM virtual hardware. But in this case, it uses a GitHub as an example. It kicks off a GitHub runner that fires off the ARM virtual hardware running on an EC2 instance, runs your tests, gives you some results, and it's a continuous integration loop like many cloud developers are familiar with, that maybe some of the embedded developers haven't utilized quite as frequently, just because running those tests on real hardware is a little more challenging. So it's a great workshop that walks through all that and continues to expand and grow into showing how to utilize all the various AWS IoT services on top of that, baseline solution.
Yeah. I'm looking at the workshop now. We'll share a link to get to this workshop, but you can also search for I think ARM virtual hardware with FreeRTOS and SimSys packs. And thanks to Paul Butler for putting this together. I know with others on your team too, Ed. But this is really great. It seems like it really pulls all the pieces together from the virtual hardware to it actually talks about virtual interfaces, which is great, and SimSys packs. And then going to Kyle Studio Cloud. So now Kyle Studio Cloud, this is a newer offering, and one that's really cool because it allows you to kick the tires, so to speak, on hardware that you don't have to do a whole lot of setup on. You can just plug in a board, and through web USB, allows you to run some demo examples fairly quickly, and you have a number of boards that you actually support for that. And that's a really cool part of it. But taking the hardware out of it and plugging in the virtual hardware, now it becomes this really great CI/CD tool to be able to do continuous development against.
Yeah, if you're just looking to get your feet wet a little bit with embedded and IoT development, this is a great way to do so, right? Because you don't need to install any tools, you don't need to go out and purchase any hardware. You can go through something like this workshop and go through the flow and see what everything looks like without really committing to any of those things. And then as you do start to commit, then you can again leverage Kyle Studio Cloud, like you said, using web USB to connect to physical boards on your desktop. There's desktop versions of those tools. Of course, our partners provide a lot of tool chains as well, and you can continue to grow from there. But getting started with this virtual environment with the cloud-based IDE is a quite powerful way to do so. And then also just getting familiar very early on with a CI/CD flow for IoT is also very powerful. And I think this really makes IoT a bit more approachable for somebody that doesn't have as deep of a background in the embedded space. So I think that's pretty exciting. I think any AWS cloud developer could become quite familiar with developing on here. Now, they might be surprised at some point when they run out of memory and run into a few other caveats that those of us with a little more experience in the space know. But a lot of the platforms these days are quite powerful and can do quite a lot at the edge. So it's a pretty great way to explore.
Sure, and the nice thing too is, so I hear a lot from people. How do I get started? With IoT, and I think one of the interesting things about IoT is there's so many ways to get started. You can start with hardware, you can start with code, you can start with cloud, and there's so many different avenues for that depending on which vendor you're using, from the hardware to the cloud to software. So what's nice about this is it really gives you kind of a good way to say this is actually a really ideal place to get started, and it's not gonna sort of lead you down one path that you may want to revisit again. This just kind of builds on on everything that ultimately you're going to have to think about anyway.
Absolutely. And I think the great thing about this workshop that Paul put together is it touches on all of these great components that you need to think about. And like you said, some of them are abstracted away with virtual hardware and so on, so that you don't need to be tied down to anything initially. But a lot of these components are things that you will continue to use. Once you start using continuous integration as part of your process and you have this structure put in place where you're utilizing ARM virtual hardware to run these components every time you check in, I think this just becomes part of the natural flow of things, and you just start depending on that in the future. So I think there are many things, even if you pick a different platform down the line, I think there's many items in this workshop that will just stick with you moving forward once you go through it and get comfortable with it.
Yeah, and another plug for Kyle Studio Cloud, that we actually have an AWS plugin for Kyle Studio Cloud that allows you to manage some of your AWS backend activities like credentials and some other things like that. So there's actually a convenience within Kyle Studio Cloud. If you're using AWS, it makes life a lot easier. You don't always have to go to the console to figure things out, which I find is really useful. Just the bit that I've used.
Yeah, any developer, any AWS developer that's familiar with using the AWS plugin for Visual Studio Code would be very familiar with this, because it is the same exact plugin, because the Kyle Studio Cloud is built on the same backend engine as Visual Studio Code. The AWS plugin works. What we did, though, was, of course, work with AWS to enhance the IoT aspect of that, because the original Visual Studio Code didn't have much of an IoT functionality built into it. But the other, as you said, the AWS account management stuff is there. That you would be familiar with from VSC.
Yeah. All right, cool. Yeah, I'm looking at the lab now, and it's great. Or sorry, the workshop now, and there's a number of different labs. So it goes through. There's it looks like there's 6 different labs actually, and kind of walks you through each of the steps in deploying a ARM virtual hardware solution. Um, Very cool. This is really excellent. I see in Lab 5 it talks about using device shadows. Um, so that's pretty neat too. You can actually use device shadows within Kyle Studio Cloud. It looks like as well.
Yeah, you can start working on a digital twin of your virtual hardware.
There you go.
That's something to wrap your head around.
Digital on digital on digital on
Yes.
digital.
Yes, indeed. And you mentioned the ARM Dev Summit coming up in October, which we are in the process of moving to a full virtual event, and so anybody around the world can now participate. So that's something to definitely take advantage of. But this workshop, we're with a virtual event. We're trying to figure out how best to do it, and so details will come within the next weeks or in the coming weeks. But this workshop will be one of the topics that we'll be focused on for Dev Summit. So, if you have a look at it and you're still not quite sure and you want to know a little bit more, join us at Dev Summit, and Paul and one of our experts, Christopher Seidel, will most likely be the ones walking you through this and kind of helping you along the way.
Yeah, that's great. Yeah, we did mention that early on when we were trying to get you on as a speaker. That Dev Summit is coming up. It's in October, so it's really just 4 or 5 weeks, 5 weeks away.
Mm-hmm.
The 26th and 27th. So the dates remain the same. Is that right?
I think that's still TBD. It's definitely that week. I think there's still some questions about whether all the content will appear on those 2 days, or if it's virtual, whether we'll kind of spread it out for a few hours across multiple days. But yeah, it's definitely going to be in that week.
Okay. All right. Yeah. So stay tuned. Visit the ARM Dev Summit site for probably the latest, and count on it being a virtual event now, as we just learned. But nonetheless, Nenad, you have a talk that's at ARM Dev Summit. I know you started talking a little bit about it. Maybe just sum up again for folks that maybe didn't hear it at the beginning.
Yeah. Yes. Thanks. Yeah. The talk, as I mentioned, would be covering some of the topics that actually we talked about now. So it's how you manage a fleet of devices and how you deploy software on them selectively. So you can group specific devices based on certain criteria, and then deploy, through this kind of CI/CD fashion, a certain software on those specific groups, and how you can perform some A/B testing as well, right? So that's kind of the topic. And it will probably use some of the components Ed was just mentioning. So it will be quite interesting.
Yeah, that's it. That'll be
In
really good.
the meantime, when we were talking, I looked at the links and I was looking at this virtual hardware stuff at ARM, and it's quite easy. Like, I was immediately able to create a new Raspberry Pi and kind of like upload my image and so forth. I'll see how that goes. Yeah, so it's quite interesting.
That's excellent. Yeah, and I'll have to plug my own talk too, which will be now converting to virtual. But I'll be talking about the Raspberry Pi Pico and using FreeRTOS symmetric multiprocessing to do to take advantage of the dual core nature of the Pi Pico and do multitasking across multiple cores. So that's what my talk is based on. Now I don't think you have a multi-core virtual hardware just yet. I think we talked about, right?
Yeah, that's right. There's not anything that's available today. Well, there's nothing available with symmetric cores, which is what you need for your for your platform.
Right.
There are a
Two
couple.
M0s.
That's
yeah.
right. We do have a couple of platforms that have Cortex A plus Cortex M. Or M plus Ethos U, or something along those lines. But you can expect to see more platforms coming in the future, and I certainly expect a multi-core platform that we could use for SMP sometime in the future.
Yeah. I think that was what I wanted to point out, is that this is an evolving effort. It sounds like, and really looking forward to what things are on the horizon. So that's great.
Yeah, from a processor standpoint, we've got our whole Cortex M portfolio there now. In fact, we have a Core Stone platform that has the Cortex M85, which is the processor core that we just announced earlier this year. There's no silicon yet available for it, but through the Core Stone 310 ARM virtual hardware platform, you could actually start working with that microcontroller today. And then the third party platforms is where we really expect to see a lot of growth in the coming time frame. So expanding upon that Raspberry Pi, NXP, and ST platforms that we have today, you should expect to see more and more platforms both in the microcontroller space as well as in the kind of application processor space coming.
Okay, excellent. So I think one topic that comes up, and just to maybe clarify a little bit, is sometimes I'm asked about Centauri and Cassini, and maybe you could give us the quick quick summary about Centauri and Cassini, and kind of how that might even fit into the ARM virtual hardware.
Yeah, that's a great question. Centauri and Cassini are both programs at ARM that we are targeting to essentially reduce the friction for developers of IoT products. And the way we're trying to do this is by, taking all the non-differentiated heavy lifting, as lots of people like to say, and standardizing that stuff. So drivers and APIs and bootloaders and a lot of these things that you absolutely need to build your IoT product. Firmware update, things that are very critical, and start to standardize those things and let the ecosystem then focus on their differentiation, their secret sauce that they're adding, either at the device level or in their application level, and spend less time worrying about how do I get this one security feature ported from platform A to platform B, and try to make that more standard. Centauri is a microcontroller focused effort around that. So it builds on things like platform security architecture and PSA certified from a security standpoint, utilizing modules like Trusted Firmware M to implement those security standards. We're starting to work in an open source community on standardizing some of the essentially driver interfaces, and our initial focus there is around firmware update, because that's a common one that everybody needs, but really having a different way to do firmware update doesn't really help anybody, right? As long as you're providing a secure, dependable, reliable method to do so, then that should just work. So we're focusing on that common device interface. CDI is an open source project that we're working towards that with a lot of partners like AWS, some of the silicon partners that we have involved. And ARM virtual hardware is a way to, kick the tires, test those things. We're using it for our own CI/CD process for that open source software, and it's also a way to distribute that for testing for others to work with.
So you could come up with your OTA strategy sort of around that too, or at least influence it. Yeah.
Yep, absolutely. And yeah, I think Lab 6 in that workshop that you're talking about is about creating and deploying jobs. So it's, using ARM virtual hardware to test out a firmware update strategy from the AWS IoT cloud service.
Yeah.
And then Cassini is a similar program, but focused on Cortex-A with rich OS solutions like Linux and Windows and some other of those types of devices. And so the idea there again is to create some commonality in the boot process. I think at Embedded World earlier this year, on the ARM booth, we had a number of different device platforms from different vendors with different chips, and we could take the same Linux OS distribution on a USB stick and plug it into each of these boards, and it just boots with the same exact vanilla Linux image. And so that's a huge value to a lot of the ecosystem. Right now they don't have to spend their effort trying to get that flavor of Linux running on the device they're trying to use. And so within the Cassini program, we have things like System Ready, which is a certification program to show that devices are compliant to boot to this particular list of operating systems in a predictable and reliable way. Similarly, on the security, we've got, again, leveraging platform security architecture and PSA certified, and various security solutions that are available in the Cortex-A space to fulfill those needs. And on top of all that, again, ARM virtual hardware as a way to test and distribute those solutions to the ecosystem.
Okay, yeah. Thanks for going over that. Sometimes we get those a little mixed up, but that was very clear. So thanks a lot.
Great.
Yeah. So let's see. I haven't done this before, but it looks like there's a few people who have joined. If there's any interest in comments or questions, we could invite somebody. I'm not sure how they show if they have a comment or question.
Yeah, I think they can raise a hand. So anybody who would like to ask a question, please raise a hand, and then we can include you in the conversation.
Yeah. So if there's any takers, feel free to go ahead and signal that. Otherwise, we'll just continue. Let's see. So I think we covered most of the topics we meant to cover. In our let's see, last maybe five or so minutes. Anything you'd like to cover that we didn't, Ed?
I think just the one other area that we talked a lot more about the microcontroller space. Just wanted to point out that from the like Cortex-A and Linux standpoint, ARM virtual hardware, we already have things like AWS Greengrass running on there today. So you can boot up one of those virtual Raspberry Pis or a virtual IMX8. You can run Greengrass and test Greengrass components on these platforms. I think there's even a workshop for the IMX8, which uses Greengrass and SageMaker Edge Manager and a few other AWS components. And we have run this workshop as well on the ARM virtual hardware. I think we're working with AWS to actually, put in a chapter about that so we could say specifically what to do. But it pretty much works. It works as is with the caveat that the ARM virtual hardware platform that we have today doesn't have the same neural network accelerator in it that the physical platform does. But from an application standpoint, you can do all that development on there.
Yeah, that's actually a really interesting point. That you could imagine having a whole system of constrained edge devices, as well as pretty beefy gateways or other types of devices, all modeled within the ARM virtual hardware. If that's a Cortex A, I mean the Raspberry Pi, the latest Raspberry Pi, that's quite a speedy processor.
Yeah, absolutely. And this is where being able to leverage an ARM native platform in the cloud like Graviton is a huge advantage. So to emulate a Raspberry Pi, which has 4 Cortex A processors in it, our virtual Raspberry Pi has 4 Cortex A processors in it as well. Actually, Neoverse processors as it stands, but they're very related. They're very close cousins of the Cortex A that's in the Graviton processor, and it's the platform parity is a word we use a lot in this space, and to be able to have that in the cloud is pretty exciting.
Yeah, I remember there was some talks about also having like a VirtIO underneath, so you can kind of like have a backend of devices and more or less you can use almost the same binaries, the same user space, the same kernel to develop your software, and then use that to kind of deploy it on the real hardware, more or less. So I thought like this was really powerful. As I mentioned, I've been working with some customers from the automotive industry. They are like really looking into this right now.
That's right. Yeah, we're doing a lot. We're having a lot of discussions as well with the AWS automotive team about software-defined vehicles and how we can leverage that parity between developing on Graviton-based processes in the cloud, maybe utilizing something like ARM virtual hardware for a more I/O representative version of the platform, and then being able to run again those same images down on ARM-based platform on the desktop, and then ultimately in the vehicle or in the factory or wherever else that device may exist, and having that continuum of kind of a container-based methodology of developing your software and then being able to deploy that at all these different levels of abstraction is quite powerful.
That's awesome. Hey, so we're rapidly approaching the top of the hour here. So I want to make sure we have enough time just to wrap up. But I also wanted to mention that beyond the Dev Summit, the ARM Dev Summit coming in October, there is reInvent coming in November, which is the AWS conference in Las Vegas, and Ed, I understand you're going to be at reInvent giving a talk.
That's right. I will be at reInvent. I'm primarily there wearing my ARM hat and discussing all the various interactions we have and activities we have going. But I'll also be there specifically presenting in the Community Builder, the developer area, a dev chat about a project that I do on the side called the Bear ID project, and basically talking about how I utilized AWS Amplify to build an application for a machine learning human in the loop machine learning process for identifying bears out in the wild. And I hope by next year to be able to talk about that as an IoT project. We certainly were working together to figure out how to get some of these, utilizing AWS services and Greengrass and some of the things that we talked about, we can start pushing these workloads out onto these ever more powerful cameras that are coming out into the market. And identify bears out in the wild in the middle of the woods.
Yeah, that's really great. I love this project. It's really cool to see your posts on it. And yeah, we'll have to have you back to talk more about Bear ID as it relates to IoT. When as you mentioned, when it's appropriate. But looking forward to your talk at reInvent, and I think I'll probably see you there. I'm going to be there as well. So definitely hook up in Las Vegas.
Yeah, sounds great. ARM will have a booth there. I'm sure we'll be demonstrating ARM virtual hardware and some of the other things that we're doing in automotive. Lots of activities around the Graviton platforms. So yeah, looking forward to it.
Great. Well, I think that's about all the time we have for today. I really want to thank Ed, our guest, for his time, and thanks so much for the great discussion, Ed. Really appreciate you taking the time and talking us through ARM virtual hardware, about the Dev Summit, about Kyle Studio Cloud, all the topics we covered. Really great stuff, and thanks a lot for your partnership as well.
Yeah, thank you, Dan and Nenad, and thank you for your patience getting my audio working at the beginning. And
I think we'll know next time to make sure everybody's on their mobile app.
I'm sure there must be a way to do it through the browser, but I just didn't have the time to try and figure it out this time around.
We are figuring this out as well.
Yes. Yeah. Thanks for having me on your inaugural episode of this, and all the luck to. I'm looking forward to the future talks that you have.
Thanks, Ed. Yeah, and that's right. This is episode 1. So thanks everyone for tuning in, and we'll be back next week. We may change the time. So that it's a little earlier in Europe, so we may shift the time somewhat. But stay tuned on the social channels to see when the time it will be. Let's see. I'm not sure what we'll be discussing next episode, but stay tuned. It will be related to IoT, and we'll see. But so I'm Dan Gross, and joining me is Nenad, and we'll be around next week around the same time on Wednesday. So until then, so long.